Welcome back. So now we're going to take up the quadratic functions recap. Da-da-da-da. So, determine whether the following are linear or quadratic. Well, let's take a look. My step pattern is plus 2, plus 2, plus 2, plus 2. If my first finite differences are all the same for plus 2's, then this is going to be linear. So let's see, 17 minus 15. So this is your first finite differences. Oh, sorry, 17 minus 5. I think that's 12. 37 minus 17. That's going to be 20. As soon as I see that, I know it's not linear. Let's look at the next one. This is going to be plus 5, plus 5, plus 5, plus 5. First finite differences, 7 minus 12, I think that's going to be negative 5. 2 minus 7, that's minus 5. Negative 3 minus 2, negative 5. Negative 8 minus negative 3, that becomes negative 8 plus 3, which is negative 5. Since these are all the same, and these are all the same, that means what we have here is a slope. All your first finite differences are the same, so this is definitely linear. So now, since there's only two options here, linear or quadratic, if this is not linear, by default it needs to be quadratic. The truth be known, the only thing I've really proven is that it is non-linear. If I want to prove that it's quadratic, I have to take a look at the second finite differences, which would be 65 minus 37, and that's getting too hard for me to do. So I'm going to get out a calculator, and it's going to be 65 minus 37. That's going to be 28. And then it's going to be 101 minus 65. And that's going to be 36. So those are your first finite differences. Your second finite differences are 20 minus 12, which is 8. 28 minus 20, which is 8. 36 minus 28, which is 8. See your second finite differences? They're all the same. That makes it quadratic. Okay? So that's how you do those. That's left over from grade 10. You need to know them. Work on those. Graph each of the following quadratics by transformations. State the transformations, the vertex, blah, 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 blah. So here's the first one. What are the transformations that I see? I see a horizontal shift to the right 1 unit. I see a vertical shift up 5 units. That means my vertex goes to 1, 5. My step pattern, the A value is 1. There's no stretch, there's no compression. So it's congruent to y equals x squared. So it's over x up x squared. X-intercepts. Well, I don't know those. I'm going to have to do those on the graph to figure them out. The y-intercept, if I set x equals to 0, it's negative 1 squared is 1 plus 5 is 6. Direction of opening, the A is greater than 0. It's positive. It's actually plus 1. So it's going to open up. Does it have a maximum or minimum value? Well, it opens up, so it's going to have a minimum. And that minimum will be from the vertex 5. I can now go and sketch everything that I want. 1, 5 is here. Over 1 up x squared. Over 1 up 1. Over 1 up 1. Already I know that it's going to look something like this. I don't really care too much. And I know that there's no x-intercepts because the vertex is above the x-axis and it opens up. So there's none. And I'm good to go. I have my vertex, I have my y-intercept, and there's no other point that I really need. Okay, let's look at the next one. Ooh, transformations. This is kind of neat. I have a reflection in x-axis. I have a vertical stretch by a multiple of 3, which means that my step pattern is going to be changed. It's going to be 3 times x squared, and it's going to open down. Now look what's happening here. There's nothing else happening with the x, so there's no horizontal shift. No horizontal shift, but there is a vertical shift. Up 12. These need to be in this order. These two have to come before the last one. I don't care which order they come in, but that one needs to be the last one, or it's wrong. Your vertex, excellent. Notice the h value in here is 0. So it's 0, 12. Step pattern, over x, down 3x squared. X-intercept, don't know that unless I graph it. Y-intercept, I'm going to set x equals to 0. If I set x equals to 0, it's 0 squared is 0 times negative 3 is 0 plus 12, so it's going to be 12. Which means right off the bat, I know that 0, 12 is on my curve. I also know that 0, 12 is my vertex. I also know that it opens down. So if I go over 1, I'm going to go down 3. 1, 2, 3. 1, 2, 3. Direction of opening, down. Maximum or minimum, it opens down, so it's a max, and its maximum value will be 12. Now, I do want to see the x-intercepts because they're going to be interesting, so I got to keep going. Over 2, down 3 times 4, which is 12. Boom chakalaka. Boom chakalaka. Again, that's a math term. And this comes down like this. Purdy. This comes down like this. Purdy. And I'm good to go. The only thing that you could do to make this any better, let's see, what are my intercepts? Negative 2 and 2. The only thing you could do is maybe sketch them. No, not sketch them, but put on the relevant information. And perhaps you want to graph it, give it a name. That's it. That's perfect. That's as best as I can do. Okay, that's done.